All right, welcome to week 4 of the countdown process. Today's warm-up is an assortment of FCAT questions from former FCAT tests. Let's see how we did. Number 1, who is correct? Put your hands down because it's a 50-50 shot. Let's survey the class. Give me a thumbs up if you think Carla was correct. 1, 2, 3 people. Put your thumbs up. Give me a thumbs up if you think Suli was correct. Overwhelmingly, the class believes Suli is correct. The correct answer is Suli. Now, it was only a 50-50 shot, so you could take a random guess and get it right, and that's not too hard. It doesn't really prove anything. So now, part B is the real work. What did Carla do wrong? What did Carla do wrong? Chanel, and then we'll come over here if we need more assistance. Chanel? That is exactly correct. Carla multiplied 2 by 3 first, which is not what you are supposed to do. Order of operations dictates that you must do exponents before you do anything else. And so if you listen to what Chanel just described, she did 2 times 3, which is 6. 6 to the second power is 36. 36 plus negative 1 is 35. And so that was the mistake. Very well, very good job explaining, Chanel. All right, number 2. What is the number? What is the number? We'll start with Tori, Ezekiel, and then Selena. Okay? All right. All right. I will actually accept both answers. The answer was supposed to be 83, but I would accept 38. Technically, when you take the difference of those, that comes out to, of 38, technically comes out to -5, but if you could rearrange the numbers, it's not really a big deal. So I will accept 83 or 38. Very good. Number 3. How many people can Chef Lopez serve? We got Joali, Briante, and then Isabella. 250 people. 141 people. So we have a slight disagreement, Jedley. What do you think? You also think it's 250 people? The correct answer is 250 people. So we basically took care of number 1 already. Number 2 was actually part of your homework assignment. Let's talk about number 3. Give me a thumbs up if you got number 3 correct. Thumbs up if you got it correct. Good. Nice. Like 2/3 of the class. Sebastian, what did you do first? How did you know you were supposed to multiply times 2? So how do you know that the 29.25 goes there? So, yeah, there you go. Very good. So here's what you were supposed to have done, and he just kind of skipped over the explanation of this, which is that you must put the 29.25 in place of the n. And then, he was right, the first step from that point is to multiply these 2 together first. And Sebastian, when you multiplied those 2 together, what did you get? Not when you multiply those 2 together, no. Yeah, you got 58.5, and then the reason you got 62.5 is because then you added the 4. So I was going to call on someone else, but he already illustrated the next step, which is now you have to add these 2 together, and that comes out to 62.5. And so here's where we're at now. P over 40 equals 62.5 over 10. Alex, did you have that step somewhere in your work?
Yes.
What'd you do at this point?
I just multiply 62.5 40.
Okay. Like that?
And then the same thing to B and 10.
Good. Cross products and then you solved?
Mhm.
Very good. Did anyone do it differently from this point forward? Corey? You multiplied 62.5 times 4. How'd you know to multiply times 4?
Because the denominator of 62.5 is 10, and the denominator of B is 40, and 10 40 is 10.
Yeah. The relationship on the bottom is times 4. The relationship on the top will be the same. So if you take 62.5 times 4, you will also get the same answer. Either way is correct. Anyone do it differently? Laura?
You can go 62.5 divided by 10 and then 40 divided by.
Very good. So you can also simplify the right-hand side and then multiply it by the 40, and you will also get the same answer. Another outstanding method. Very good. Anyone have any comments or questions about number 3? Anyone have any comments, questions about anything? Very good. Please put this warm up to the side. So, as you already know, this is week 4. If you would open the packet, which you either already have or is at the moment being handed back towards you, if in the packet you would turn to week 4 and find day 16. It says the day number at the bottom of the page. Please find day 16. So, you are going to do 5 questions in 10 minutes. Remember that your score for the first set doesn't matter. Your effort matters, and what you know and what you don't know matter. But your score doesn't matter. You work hard, you try your best, you do your best to get the right answers. Also, you need the reference sheet. It's the first page in the packet. One little warning. I had several students who used the reference sheet during a lesson this morning, and then when they turned back to the page that they were supposed to be doing, they accidentally turned to the wrong page and finished the wrong page. So please just be aware of that and just make sure that when you flip back to where you are, to just make sure you're back to the same page we're working on. Anyone have any questions on what you're going to do? Remember, this first set is an individual activity. You will not get help from me, and you will not get help from anyone else in the room. Go ahead and begin. All right. First set of questions. Time is up. Pencils down, colored pens come up. Remember that how you end up doing on this set doesn't matter. Mark your answers honestly and fairly, and then we will go over all of it. Number 1 is 80. Number 2 is A. Number 3 is F. Number 4 is C. Number 5 is I.
He said that too long.
So, I need to do pretty much 5 mini lessons today, but I'm not going to do all 5 after the first set. We're going to do 2 or 3 of them, it kind of depends. And then you're going to have the second set, we'll see how we do, and then I'm going to do the last 2 mini lessons. So, I am not surveying how we did overall, but I will be surveying question by question. I'm pretty sure I already know the survey, the results of the survey for this, but give me a thumbs up if you got number 1 correct. That's what I expected. Put your thumbs down. There are two issues with this. 2 issues with this question. Pay close attention, and you've got your colored pen ready. You're going to have to write, you're going to have to draw, you're going to have to pay attention. Okay? First of all, you guys didn't read. You think you read it, but you didn't. Secondly, is you're having trouble understanding spatial relationships. And so I'm going to spend most of my time helping you see the spatial relationships. So let's start with that. So you unfortunately were not allowed to draw in these packets. But when you get the FCAT, you are allowed to draw all over the booklet. And they've done studies. They've taken test booklets from students, and they basically divided them into 2 piles. I'm simplifying a little bit, but that's basically what they did. They said, this student wrote in the book, this student didn't write in the book. This student wrote in the book, this student wrote in the book, this student didn't write in the book, this student didn't write in the book. They made 2 piles. Then they compared the scores of the 2 piles. The average score for the pile where the students wrote in the book was much higher than the pile of students who didn't write in the book. The message is clear. The more you write in the book, the better off you are. Now that doesn't mean if you write a story about your best friend, instead of doing the questions, that you're going to do really well on the FCAT. Of course not. If you draw a picture of an alien while you're supposed to be testing, of course, that does not mean you're going to do well. But if you actually write notes or diagrams or enhance the diagrams that are in the booklet, you will do better. It is almost guaranteed. So, you were not allowed to write in these, but you could have redrawn the picture, and it wouldn't have been that hard to do. So I've done that right here. I've redrawn the picture. Now, the first question is, how many small blocks fit into a large block? Let's see what you think. Raise your hand. How many small blocks fit into a large block? 4. How many did you think? 4. I saw that a lot. Corey? 8. You think 8 of those fit into that? Okay, what did you think?
No, it's
8? You also think it's 8? Okay, so let's do this. Let's do this. Everyone watch carefully. Oh, excuse me. Everyone watch carefully. How many blocks do you think are going to fit in now? Raise your hand and answer my question. You had your first thought. Now what's your thought? Isabella? Now you think 8? Now you think 8. Michael, do you want to stick with your original thought? You still think it's 8? Let me add to the picture. Now how many do you think are going to fit in? How many do you think are going to fit in now? Gary? 8? You think 8 are going to fit in? Let's try this. Now, how many do you think are going to fit in? Deadly, how many do you think?
8.
You think 8? Selena? You think 6? Let's see.
There's more room.
There's
Oh,
5, 6, 7, and now the picture. Now the picture's a little bit harder to decipher, but hopefully you watched as I put the boxes in, and even looking at it, you can pretty much see that there are 8 small boxes in the large box. So let me rewind this for a second. Okay, and so now we have determined that 1 large is going to equal 8 small. Why is the answer not 8? The answer should be 8, right? Why is the answer not 8, Briante?
Because he said he used 5 large blocks by 2 large blocks.
Yeah. When I said that you guys didn't read, what I meant was you think you read, but you did not read. We have this magical character named Jeff who's building a wall. He's building a wall out of 5 large blocks long and 2 large blocks high. And so now, let us take a look at what Jeff is building. So, here is Jeff's project. He's got a large block, and then he's going to take another large block and put it on top. Then he's going to do this. And he's building a wall. And so, how many blocks does Jeff use for his wall? How many blocks does Jeff use for his wall? Corey, you did a great job of drawing a picture of this, and there were several students who did. And so, how many large blocks does he use?
I thought it was 2 blocks thick.
Right. But now, just based on my picture, how many blocks does he use? 10. Very good. So you can clearly see 10 large blocks right here. But now we have to combine the 2 ideas. We have this idea and this idea. The question actually asks you, how many small blocks does he need to build a wall with the same volume as the large blocks? And so now there's several different ways to think of it. You can think of it this way. There are 8 small blocks that would fit in there, and 8, and 8, and 8, and 8, and 8, 8, 8, 8, and 8. Can someone simplify what I just did in a simple little expression? Gloria? 8 times 10. 8 times 10 is 80, and that is why the answer was 80. Does anyone have any questions about this? Now, would it be practical to sit on the FCAT test and draw this picture? I don't think so. So let me do it in a different way that might help you save time and still get the same results. So now I want you to look at the large block again. I'm going to make it much bigger so that we can see a little bit better. And now, you have to pay attention to this. Because I didn't talk to you about this because I assumed you already understood. But that means that this distance right here, from here to here, is half the distance from here to here. And so what that means is, if I take a small block and put it right over here, that it's going to fit halfway across. So could someone tell us, how many could I fit going across right there? Yvonne? 2. So watch this. There's 1, there's 2. But now watch. It says here that the length is also half, which means the distance from here to here is half of the distance from here to here. So if I put a block in over here, that means that the length is going to be halfway. So how many can I fit going across there? Isabella? 2. So let me just enhance this over here. And so now there's 2 going this way. Watch carefully up here so you see the magic. Now there's a half, and unfortunately this was a typo. That was supposed to say H. And it says W on all of them, so just make sure you realize that that's an H. Half the height, which means this distance right here is half of that distance. So how many blocks would stack up here if I put them in? Gary? 2. So watch this. There's 1, there's 2. Now watch. Put that point here, put that point here, put this point here, put that point there, and now watch what happens. When you connect all the dots, now you can see all the blocks. If I continued it up on top as well, it might be even more clear. Now you can see all 8 blocks. You can see 1, 2, 3, 4, 5, 6, 7, and the only one you can't see is the 8th one in the bottom in the back. But you could understand that it's there. And so this is another way to achieve the same thing that I had achieved earlier when I kept dragging this one into that one. So you have to be able to do something like this. I was just talking a couple minutes ago about students who write in the book. That's what I'm talking about. Draw that in your book, and that's going to give you a huge advantage as far as answering the question. So I just went over a whole bunch of stuff about spatial relationships, reading, and geometry and math, computation. Anyone have any comments or questions about number 1? Anything at all? Corey? About number 1. Okay? Good. So now we're going to take a look at number 2. Give me a thumbs up if you got number 2 correct. Good. A lot of people. And good. So I'm not going to spend a lot of time, but I do want to clarify a couple of things because the next question that you're going to see is a little bit harder. First of all, let's talk quickly about these 2 words. Clockwise and counterclockwise. Can I have a volunteer put that into easier terminology? What does clockwise mean and what does counterclockwise mean? Janae?
Okay, clockwise is going the way of the clock, right? And then counterclockwise is going the opposite way.
Very good. So if you look at my clock up on the wall, you can see the red hand, the second hand, moving in this direction. That's clockwise. Counterclockwise, as she said, is the opposite. So it makes a huge difference, okay? Anyone have any questions about that? Now, 2 other words we need to clarify. Rotation. What does rotation mean? Paige? Spin something or turn something. Very good. What about translation? What is a translation? Valerie? Yeah. Translation is move over. Another way to say it, I'm going to do something with the word. In the middle of the word is an SL. Does anyone know of another word that we can use in place of translation? Alex? Slide. A translation is a slide. Okay? Anyone have any questions or comments? So here's what it is. Here is the shape. The rotation goes like this. That's rotation. Okay? So the question was, what did you have to do to the shape to make it fit into the puzzle? And you had to do a 90-degree clockwise rotation. Then you had to translate or slide it over. That's what you were asked to figure out. So, any questions about that? Jedley? Okay, so the last thing I want to clarify is this phrase, about point S. The point that you rotate around actually makes a huge difference. So now I want you to look over on my whiteboard. I'm not going to illustrate up there because it's harder. So I made my own little version of the shape up here. And I put a magnet in the middle, and so I put that at approximately where S was. So watch how it rotates when S is in the middle. But now, what am I talking about? Watch this. What if I moved S over to here? Now watch what happens when I rotate it. It's a totally different rotation. Okay? So if I take the shape and I rotate it from here, that affects the shape in one way. If I move S to a different spot and then rotate it, it affects it in a totally different way. So when it says about point S, that's actually really important. That's telling you how it's going to rotate. In this case, when S is in the middle, it's just going to rotate around itself. But if S were in one of the corners, then that would be different. Any questions about that? Good. So we should have enough to generate some improvement for the next set of questions. So we did 2 mini lessons. We're going to do 2 more after the next set. Anyone have any quick comments or questions? All right. So now everyone turn to day 17. Make sure you are on the correct day. Day 17. Now you are going to have 8 minutes for 5 questions. Anyone have any comments or concerns? All right, 8 minutes on the clock. You may go ahead and begin. All right, time for set number 2 is up. Now your score counts. Colored pens up, pencils are down. Here we go. Number 1, 192. Number 2, I will accept A or B because of a typo. It was the same answer, A or B. Number 3, the answer is G. Number 4, the answer is B. And number 5, the answer is F. So, write down your percent for that set. Give me a thumbs up if you got 80% or better. Good. Put your thumbs down. Give me a thumbs up if you improved since the first set. Good. Put your thumbs down. So now, I went over numbers 1 and 2 in the previous. Number 2, introduced another word. What was the word in number 2 that was introduced that we didn't see in the first question? Michaela? Reflection. And so we have to understand what a reflection is. A reflection is a mirror image. A reflection works like this. You have a shape such as this right here. Then you need a mirror. A mirror is just a vertical line or a horizontal line. So that's a mirror. And so the shape gets reflected over, and so it will become a mirror image of itself. That's different than sliding. Okay? And so that is what has happened in this question. I'm sorry, not in this one. This one you could do the rotation. Sorry. So it was a rotation, but if you look, a reflection would actually work as well. If you reflected it about there, this shape would end up right about there. Okay? So reflection is another type of transformation that you can do to a shape. We're going to talk more about reflections in the future. Now I want to get to 2 questions that we didn't get to before. Question numbers 3 and 4. Let's look at number 3. Give me a thumbs up if you got it correct. Okay, put your thumbs down. So we got some work to do. Chanel, what did you do to get it right? What was your proportion? What does it simplify to? 3/4. Okay? Okay, so when you say proportion, this is just a ratio. A proportion would be if it had the other side. So you're saying you did a ratio? Okay, just wanted to clarify for everybody else. So this is a great method because when you convert multiple measurements from one unit to another, that's a proportional change. They're all changing at the same rate. So if you can find the choice, in this case it was G, the choice that matches up, this turns into 3/4. If you look at 30 over 40, put that in simplest form, that also turns out to 3/4. And so it doesn't really matter what the units are, as long as these units are the same and then these units are the same, they will be in proportion. Anyone do it differently? Paige, what did you do? Okay? Okay, 100 over 75, and you divided, what did you get? Okay, 1.3 repeating. Good, what did you do next? Okay, well, you did get a little bit lucky, because if you just did the first one by the second one, you actually made a mistake. Because it had to be the bigger one divided by the smaller one. And in F, the bigger one came second, not first. So you would have had to do 60 divided by 49. But you got a little bit lucky. So you got a little bit lucky. You did happen to pick the right answer. And it is a good way of doing it. And so if you do 40 over 30, that also comes to 1.3 repeating. This is pretty much the same method that Chanel used. Pretty much, just looked at slightly differently. Anyone do it yet a different way? Gloria?
Well, for each one of them, I did like 75 over 100, and then like after the time, and then I did like the other one, like but I put it in like proportion for like F right now. I was wait. Remember what I did? Oh, you put 60 over 49, and then you like cross.
Okay, so you did 49 over 60. It would have to be that way because the smaller number had to be on top. And so again, if you're converting the same unit of measurement to a different unit of measurement, as long as you're converting both of the same thing, you do the cross products, it should come out to a proportion. So F did not work. So then you would have to back up and try the next one. And then you would do 30 over 40, and then you would notice that it comes out the same. Okay? Garion, what did you do?
What I did was I took the length and the height, and I divided both of them separately by 2.54.
Very good.
Them into inches.
Yeah, where'd you get the 2.54 from?
I got it from the reference sheet, which stated that 2.54 centimeters go into 1 inch.
That's right. 2.54 centimeters equals 1 inch. And so you use the conversion factor, and you do 100 divided by 2.54, and then you do 75 divided by 2.54, and you don't get exact answers, but you get close to 30 and 40.
That was like 39.
Yeah, it was.
39 and 29.
That's right. It comes out to about 29 and about 39, and you see that G is the closest answer. Very good. Any comments, questions, concerns? Corey? Okay, any follow-up on number 3? All right, let's take a look at number 4. Number 4 was different on the second set than it was on the first. Very different. What was different the second time around? What was a big difference? Yadesh? Yeah, there were no numbers on this at all. So the question is, if 100 readers responded, how many approximately chose museums? So give me a thumbs up if you got number 4 correct. Good. Chris, what'd you do?
600, that's total. So, zero is basically 50 without out of the mall, and then historical places and parks are 25 each.
Okay, hold on. How do you know that they're 25 each?
Because since the museum is half, and they just half.
Okay, so are you looking at it like this and this here? Like that?
Yeah.
Okay. And so the part I outlined in blue would constitute how many? 50. Right. Because the whole thing represents 100 people. This is half of it. That must be 50 people. Half of 100 is 50. Then you took it a step further and you put the line in here. And so historical places is how many? So this is 25% or 25 people. And this is 25% or 25 people. Oops. 25% or 25 people. And so that leaves that top half to be 50% as well. Very good. Go ahead, Chris, continue.
And so since 9 equals 50 already, so if you move to the old 50 and 35 would be like way too much, would be like over the half. So I'll the only solution I can find was 80, 45.
Okay. So again, he's looking up here. I didn't draw that very well, but he's looking at the top half, and he's saying to himself, well, that's 50%. But now the outlet malls is taking up this chunk, this little slice right here. And I have to estimate this. So we already know that it's not 90. We already know it's not 50. So it's 35 or 45. And your gut was telling you that 35 would be too small because that would be more like up here, right? So you figured that's got to be about 45. And that was an excellent way of doing it. Very good. Anyone do it completely differently? Caesar? Okay. Ezekiel? Okay. Good. Anyone do it in any other way that we could duplicate? Jedley?
Well, I saw that like the parts of this growing places is like 25, and the outlet bulb was almost half of that.
Okay.
More than half of that. So what I did was I divided 25, and I got 12.5.
Good.
So I subtracted 50 from 12.5.
You mean you subtracted 12.5 from 50? Good. That was a great way of doing it. Good job. Okay, any follow-up questions on number 4? Corey?
I thought that since the element was that big, but it was 5% and 5% fit in one of the bottoms, and it didn't look like it's almost the same, it was like 50%.
Okay, so you picked 35? Yeah, I mean, look, 35 is definitely not a bad choice. It's definitely close. This is a tough question. If to make this fair, I would probably want to make this more fair, I would either make this a little bit smaller, like you said, it looks a little too big. I would have probably made this slice a little bit smaller to make it very clear. Okay? Good. So, we're looking for improvement. Last set of questions. Everyone turn and make sure you are doing day 18. Day 18 only. Make sure you are on day 18. We reduced the time again. However, be aware that several of the questions are harder than the previous versions. So pay close attention to what you're doing. You got 7 minutes for 5 questions. Go ahead and begin. All right. Time's up. Pencils down, colored pens. Last chance for improvement. Let's see how we did. Number 1 was 270. 270. Number 2 was C. Number 3 is G. Number 4 is C. And number 5 is G.
Right. But I got 40. I got 40.
I went down.
Oh, wait.
I don't know about them.
I went down by.
All right.
Okay, I get it.
So, though I didn't really ask you to announce how you did, seems as though a lot of people have already started sharing. Give me a thumbs up if you got 80% or above. Okay, put your thumbs down. So, quite a bit less than the last one. But I did tell you that the questions were going to get harder. So, that's perfectly reasonable. But now we need to improve again to try and understand where we went wrong. So let's take a look at number 1. It's the same question except one dramatic thing changed. What was the big change for the question now? Kiana?
That the dimensions of the small blocks are 1/3 of the size of the large block.
Great, you said that beautifully. So now someone fill in this for me. One large block equals blank small blocks. Let's see who can answer that with some confidence. We've got 3 people. What did you think, Joelle? What did you think, Isabella? What did you think?
27.
It is 27. If you had followed my technique that I had demonstrated towards the beginning here of drawing in, you would have seen, and I'm not saying it was easy, but you would have seen that 3 would fit across here. 3 fit that way, and 3 fit this way, and 3 fit this way. Let's put it even simpler. 3, 3, 3, and 3. Could someone tell us what do we get when we do 3 times 3 times 3? 27. So there are 27, sorry, I forgot a point here. 27 small blocks fit into a large, and then this magical character named Jeff is building a wall 5 large by 2. So he's got 10 large blocks, so 27 times 10 is 270.
I get it.
Anyone have any comments or questions on that? Something else, Joelle? Okay. So number 2. A lot of people got number 2 wrong, or at least it seemed like it, because there was lots of grumbling and groaning. So I think possibly some of you saw A and put A. Give me a thumbs up if you put A as your answer. Okay, so I'm wrong. So what did you put as your answer? Someone raise their hand and tell us what you put if you got it wrong. What did you put? Katie? You put B. So 180 degrees. Do you know what will happen when you turn something 180 degrees? It would be basically flipped around. So this shape, let me do this real quick. Let me show you, rather than try and explain, let me show you really fast. Give me a second. Give me a second. So, that's the shape. Here's 180 degrees. That's 180. If you look at it now, there is absolutely no way to fit it into that spot. So, it can't be a 180 degree turn. 90 degrees clockwise, as Danae explained earlier, clockwise is going this way. And again, there is no way to make that fit into there. So it had to be the counterclockwise. Okay? Any comments, questions, concerns about that? Kivan?
See, after I got my answers, I checked it. I thought I knew it was C, but I was like, right.
Oh. Okay, well that's an honest mistake, just don't make it again on the FCAT, okay? All right, now, any questions on 3, 4, or 5? Okay, we'll start with Valerie, Paige, and then over here. Valerie.
Okay, so number 3, I got it wrong. I don't know.
Well, what did you put as your answer?
I. Same.
You put I? Okay. And what was the correct answer?
G.
The correct answer was G. Okay, so let's check. So if we just do Garion's method of actually converting the numbers, we can use the conversion factor 2.5 centimeters equals 1 inch. So everyone's got their colored pen ready to try it out. Use your calculator. That means that if we have centimeters, we need to divide by this to turn it into inches. So we've got 90 divided by 2.54. So let's check in a calculator. 90 divided by 2.54 equals 35.4. Okay? So maybe you stopped right there and looked for the 35 and you said that that was the answer. That's possible. Okay, so this comes out to approximately 35. But now let's check the other measurement. 160 divided by 2.54. Pick up your calculator. 160 divided by 2.54. And it comes out to 62.9, comes out to about 63. So it looks like I made a mistake. Yeah, so clearly I made a mistake. I honestly have no idea what I... Oh, I know what I did. I know what I did, so I apologize. I know exactly what I did. I made... Excuse me. So I apologize for the mistake. You guys were right. The correct answer was I. So let me go back and just make sure you see it here. That this number 3, this number 3 was I. Number 3 was I. So I apologize for that. So go back and change your score. So I'm sure for some of you that brought your score up. For others that may have unfortunately brought it down. But okay. So I'll get to you in a moment, but I believe I had Joelle and Isabella and someone else had questions. Who's next? Paige, you were next? Go ahead, Paige.
Okay, so for number 4, I got it right, but I don't know how. I just kind of guessed.
Okay. Well, this whole scenario can be broken down into a statement that looks like this. That's what I spend time working with you on, is translating situations into simple statements so that then we could use our proportion method to solve it. So could someone help me fill in my blanks? I have blank percent of blank. Could you fill in something for me? You should be able to. Did I?
It is, okay, I know after the is it 160?
Good. So stop right there. The of is 160 because we're saying what percent of 160. Okay? But unfortunately, the percent was not just given to us. So now we have to do some estimating like we did before. So we have to take a guess, a good guess, as to what percent is really represented by this slice of pie right there. So what percent did you use for this? Celine? 45? Is that what you said? So now we can fill in this. 45% of 160. Now my advanced students have shortcuts and quick ways to do this. If you weren't ready for that, here's what you learned. Proportion method with 100 here, 45 here, and the of goes here. And solve the proportion and you will get your answer. Unfortunately, if you picked a number here that was way off, since you had to estimate it, you probably had trouble finding the right answer. Okay? But if you think about the last question we did, the last one here, we got the answer of 45. So we actually sort of already did that work where we estimated that that was 45. And then we used that information here. Okay? Corey, you wanted to add something?
I think they really good stuff. Because I'm like, it looks bigger than it really is, so it's obviously B, right?
Okay? Well, let's do this. Let's take 55 and put it out of 160. 55 divided by 160 equals 34%. So you're saying that 34% shows museums. 25% would be here. You're saying this whole thing would be 34%. That seems like more than 34% to me. It's definitely a little too close, but if you do, what was the answer, C?
Yes.
So 72 divided by 160 comes out to exactly 45%. Okay? Comments, questions, concerns? I know there was other people who had their hands raised. Okay? Draw a line across your paper. Your homework is Countdown Week 4, Day 19, the NGSSS workbook, page A21 to A22. And your next quiz is on Thursday. And that will be Countdown 4 to Countdown 6, which clearly we haven't done yet, but will be done by then.